Hello, this lesson is about Unit 3, Standards 2 and 3, and this one's about, we're doing derivatives of sine and cosine, and also it should be a review about product rule and quotient rule. So on the left side of your notes, you'll notice that we have a graph of sine and cosine. I could derive it for you or show you the proof for these, but I just want to show you, I want to show you what the actual derivative of sine and cosine is. So this is something that you're going to use like all the time for AP Calculus. You're going to use it and you need to memorize it for the whole year. Derivative of sine is cosine. Okay, so every time you see sine, you can turn it into cosine if I'm taking its derivative. And derivative of cosine is negative sine. And for some reason, people always forget which one's negative, which one. You should know that sine goes into cosine and cosine goes into negative sine. So to review the product rule, you may have forgotten it. I have the rule written out for you right here. The formula is written out for you. But I'll show you a couple examples to help you memorize the product rule, or the way that I memorize the product rule. So say, for example, you have this problem. It's here on the left. And it says I want the derivative of 3x to the fourth equal 3x to the fourth sine x. So what I'm going to do is I'm going to consider this as two pieces. Piece 1 is 3x to the fourth, and piece 2 is sine x. The product rule, and you can see that these are two terms that are being multiplied. Okay. The product rule says when you have two things that are multiplied, you take the derivative of the first one, which I will call f, and leave the second one alone and multiply the two. Okay. Plus, you leave the first one alone and the derivative of the second one. That's all the product rule is. Derivative of the first one, leave the second one alone, plus leave the first one alone and derivative of the second one. So I'm just going to follow the rules as it says. So the very first one says 3x. I need to take the derivative of the first one, which is 12x to the third, and I'll leave the second one alone. Okay. And then I'll do the same thing, except for I will leave the first one alone and derivative of the second one, which in this case is cosine x. And that's all that you need to do for the product rule. Okay, might take you a little time to remember how to do these, but that's really all you do. Okay, going on to the second example, you may notice there are actually three pieces to this. There's this one, and there's this one. You'll notice that the 7x, which is out here, is not part of the product rule because there's a minus sign. So this is a product rule, these two things over here. But this thing is its own thing. Okay, and you already know the derivative of 7x is 7. Okay, so that's that. Then I have this minus, and what I'm going to do is I'm going to do the product rule to the second part of this, Okay, so I have the derivative of the first one, okay, which is, I'm going to use brackets here. Derivative of the first one is 2x, and I'll leave the second one alone. Okay, plus, leave the first one alone, and derivative of the second one, and some of you may have forgotten, the derivative of cosine is negative sine x. Okay, so far? And then all I have to do is simplify this. This is where it gets really tricky. The reason why it's a more difficult problem is there's this minus sign here. So all I do is leave the minus sign there and do the product rule for these two pieces. So it's 7 minus, first of all, I'm going to simplify what's inside the brackets. Okay, so 2x cosine x plus, minus x squared sine x. Okay, and all I'm going to do left is apply this minus sign, or distribute this minus sign out here, and I'm done with the problem. So it's going to be 7 minus 2x cosine x plus x squared sine x. And that's all there is to it, to the product rule. In your notes, we talked about doing this for three functions. This is something that they don't test you on the AP exam anymore, so we're not going to go over product rule for three functions. Okay. Now, two more examples about the product rule to see if you understand this. First one says, find the derivative with and without using the product rule and compare your answers to make sure it's the same. So basically, I'm going to prove that the product rule works. Okay. So the very first thing I'm going to do, I'm going to try it without the product rule. Okay. Try it without the product rule. This one is kind of like FOIL. Okay. So I'm going to multiply first the 3x to the fourth to all three terms in the second parentheses. Okay. So I get 3x to the sixth minus 12x to the fifth plus 6x to the fourth. Okay, then I'll distribute this minus 5 to all three also. So I get minus 5x squared plus 20x minus 10. Okay, pretty long, but I've done it, right? I've just multiplied it out. There's nothing I can combine here. There's no like terms here, so all I'm going to do is just apply the derivative. The first one, 3 times 6 is 18, and I'll subtract 1. Second one, 12 times 5 is 60, I'll subtract 1. 6 times 4 is 24, I'll subtract 1. 5 times 2 is 10, I'll subtract 1. And then 20x derivative is 20. And then negative or minus 10, there's no derivative. So that's the derivative without using the product rule. If this is correct, I can use the product rule and I should get the exact same answer. Okay, so let's try it with the product rule. I'll use it in a different color. Okay, so if I'm using the product rule, I'll take the derivative of the first one. Derivative of the first one is, and I'll do it on this side. Derivative of the first one is 12x to the third. And that's it. That's the derivative of the first one. Then I leave the second one alone. Okay. Plus, I'm running out of space here, sorry. Plus, I'll leave the first one alone, which in this case is 3x to the fourth minus 5, times the derivative of the second one, which in this case is 2x minus 4. Okay, so I'm just applying the product rule. Took the derivative of the first one, leave the second one alone, and then took the derivative of left the first one alone and took the derivative of the second one and added the two together. Okay, now let's simplify this and see if we get the same answer as we did the first time. In the first term, before the plus sign, I have another, I'm going to distribute this 12x to the third. So I'm going to get 12x to the fifth minus 48x to the fourth plus 24x to the third. Okay, so all I do is distribute that 12x to the third. Okay. After the plus sign, I have a FOIL. So I'm going to have to FOIL the right side or after the plus sign. Okay, so if I FOIL that, I'm going to get plus 6x to the fifth minus 12x to the fourth minus 10x plus 20. Okay, so far? You'll see here that there are a couple of things that combine here, so I'm going to have to combine some like terms. You'll notice that I have 2x to the fifths and I have 2x to the fourth, so I'll combine those. If I combine the first one, the x to the fifth, I'm going to get 18x to the fifth. If I combine the x to the fourth, I get minus 60x to the fourth. I get plus 24x to the third. I get minus 10x, and I get a plus 20. Okay. If I look back at my original problem that I did without the product rule, you'll notice that they're exactly the same answer. Okay, so this is just a proof that the product rule works. Okay, and the last thing for product rule, it says find equations of tangent and normal lines. Again, for this example, we're not going to do normal lines, but you should know how to do a tangent line. Anytime they ask you about an equation of a tangent line, you'll start the exact same way. Y minus y1 equals mx minus x1. They always give you x, so it looks like that. And to find y, I'm going to plug in x. So if I plug in x here, I'm going to get 3 pi squared minus pi, okay, which doesn't simplify, times sine of pi. If you forgot what sine of pi is, in my unit circle, sine of pi is here, which is -1, 0. Okay, and sine is the y-coordinate, so sine of pi is 0. Okay, so again, I get 3 pi squared minus pi times 0, which is 0. So this left side just becomes y. I'm almost done finding the equation. All I have to do is find m. If you remember to find m, I'm going to take the derivative and plug in x. This is a product rule problem. You see I have one thing here and another thing here. I'm multiplying two terms, so I'll apply the product rule. Okay, which is the derivative of the first one, 6x minus 1, leave the second one alone, plus, leave the first one alone, and derivative of the second one, derivative of sine, as we talked about earlier in this video, is cosine x. Okay. Now I will plug in pi. On the first part, I get 6 pi minus 1. And remember, sine of pi is 0. Plus, I'm going to get 3 pi squared minus pi. And then cosine of pi is -1. So if I do this correctly, this part goes away because I'm multiplying by 0. And this part, if I distribute the minus, I'm going to get -3 pi squared plus pi. And that cannot be simplified. This is my slope. That goes into here. And that is my answer. Y equals -3 pi squared plus pi, parentheses, x minus pi. You could simplify that even more, but again, for the AP exam, it's still the right answer. You don't have to simplify any further if this is a free response problem. And that's the product rule. Okay. Now, going to the next page, we'll talk about the quotient rule. Quotient rule almost looks exactly the same as the product rule, with two big exceptions. It's derivative of the first one, leave the second one alone. And instead of a plus, it's now minus. Okay, and leave the first one alone and derivative of the second one. Okay, and the second piece that makes it different. So the first thing that makes it different is now it's a minus sign, and the second thing is that on the bottom you're going to do the denominator squared. Okay, so let me show you what that looks like. This first one, I see clearly that this is a quotient rule because I'm dividing two functions. So let's apply the quotient rule. Derivative of the first one. So that's the derivative of the first one, or the numerator, and I'll leave the second one, or the denominator, alone. This time it's minus, leave the first one alone, times the derivative of the second one, okay, which in this case is 2x. And then the new piece, again, is going to be all over the denominator squared. My denominator is x squared plus 4, so I'm going to square that. Okay, for calculus, for the most part, they never make you go far or simplify this any further. So for this class, this is all you need to get to. Okay, you don't need to multiply it out, don't need to FOIL it, nothing will cancel. You'll keep it there. For the AP exam, they may ask you to plug in a number. Maybe they'll ask you to plug in 1 or 0, but that's as far as you need to go. Okay. We'll do the last example. We'll skip one over and we'll do this one. And the reason why we're going to do this one is that you'll notice that there's actually two rules in play here. Okay. First of all, if I asked you which rule am I using, you may notice that this looks like a quotient rule, right? It's a fraction, so this is a quotient rule. But in the numerator, I'm multiplying two things. So if you think about it this way, I have a product rule that's inside of a quotient rule. Okay. The outside function, the one that I'm doing first, like if this is order of operations, is this division. This division is the most outside function. Okay, so I'm going to apply the quotient rule. Okay, the quotient rule says take the derivative of the first one, and the derivative of the first one is the product rule. Okay, so think of it this way: if I write out my quotient rule formula, when I'm doing f prime, I'm doing the derivative of the numerator. Okay, so let's do the derivative of the numerator, which is a product rule. Okay, which is derivative of the first one, which is 6x squared. Leave the second one alone, cosine x, plus leave the first one alone, 2x to the third, and derivative the second one, derivative of cosine is negative sine x. Okay, so that is the derivative of the first one. Okay, but I haven't figured out. Remember, this is the quotient rule. I still have to do g minus f g prime and g squared still. Okay, this piece that I just did is just f prime. Okay, now, and I'm going to run out of space here. How about this? I'll rewrite it down here. 6x squared cosine x plus 2x to the third negative sine x, and that's the first one. Okay, this is the first one. Now I will leave the second one alone. In this problem, in this quotient rule problem, the second one is x squared minus 7. Minus, leave the first one alone. Remember, the first one is 2x to the third cosine x. Okay, and the derivative of the second one, or the denominator, in this case it's 2x, and this is all over the derivative, or sorry, the denominator squared. And that is how you do the quotient rule. Again, you could simplify this even more, and some of you may think this is really ugly, but that's how you solve these types of problems. So, and then on the bottom of the notes, it's more practice about equations of tangent line, which I think you know how to do already. So that is this standard. Again, this standard is about sine and cosine, the derivatives of sine and cosine, and product and quotient rule. Okay. So if you have any questions, again, you can see me in class. We're gonna practice this in class when I see y'all next. So take care and see y'all later.